Hello friends, today we are going to see the trick to solve ball-based sums under the topic of probability. More specifically, we are going to see the trick for with or without replacement sum or with or without noted sums. Okay, so before going to the trick, let us see some concepts that are helpful to solve this type of sum. Okay, in all the ball-based sums, we are going to have a selection, and for selection, we are going to use the combination formula. Okay, hope so you know the combination formula. For combination, we use the formula of NCR, that is n factorial upon r factorial n minus r factorial. For NCR, we usually use this formula, but to save time, you can use this trick. Okay, let's say you have to get 5C3. So instead of writing it as 5 factorial, then 3 factorial into 5 minus 3 will be 2 factorial, then simplifying it like 5 into 4 into 3 factorial, then cancelled, and then upon 2 into 1. Okay, so now you will get answer as 10. Okay, but the trick to solve this is you have to write it as like this: 5 into 4 into 3. Okay, you have to reduce this number 5 to 3 times. Okay, 5 into 4 into 3, and then reduce 3 to 1, 3 into 2 into 1. Okay, so you can see you directly reach to these steps, and then you can simplify it very easily. This 3 got cancelled, and this will be 20 by 2, basically 10. Okay, so you can see if you use this basic trick, you can save some time. Okay, along with this, you should know the property of combination, that is NC1 will be always n, NCN will be always n, and also NCR is basically NCN minus r. This is very handy, you should take note of it. Okay, these are also handy, but it will save more time. Okay, so what I'm saying is, let's say you have to find 10C8. So what you will do, you will reduce 10 to 8 times. Okay, 10, 9, 8 and so on. Then you are going to reduce 8 into and so on. But by this property, what you can do is 10 minus 8 will be 2, right? So you can write it as 10C2. So now what you will do, 10 into 9 upon 2 into 1. Okay, so the answer will be 45. Okay, from both of this you are going to have the same answer, but this step is lengthier as compared to this. Okay, so it's better to know this property also. Along with this combination, we are going to use this formula also, that is required probability equals to favorable upon total number. Okay, so this was the basic that you should know it. Now let's see the sum, and there only we will see the trick. Okay, so let's see first sum. This is of CE 2018. Probability of picking 3 red balls without replacement from a box containing 5 red balls and 1 white ball. So you can see this sum is of without replacement part. Okay, so the best way to solve this type of sum is you have to get 3 red ball. Okay, and we know the total ball is 6 ball, and among these 5 are red balls. Okay, so what we are going to have, we are going to select 3 red balls from 5 red balls, right? 5C3, we are going to select 3 red balls from 5 red ball. Okay, upon, we know the basic formula of probability, right? Favorable upon total, right? So here we have a favorable upon total. Total we have 6 balls. Okay, and among the 6 balls we are picking 3 ball, right? So 63. Okay, so if you simplify it, you will get 5 into 4 into 3 upon 3 into 2 into 1 upon 6 into 5 into 4 upon 3 into 2 into 1. Okay, so you can see this are going to be cancelled, and you will have only this 5 into 4 into 3 upon 6 into 5 into 4. I am writing this because it has a meaning that we will get afterwards. Okay, so now you can see you can cancel this thing, you can cancel this thing, so the answer will be 3 by 6, basically 1 by 2. So this is your answer. You should take note of it always. When you get the same value at the lower end of this combination, then this is going to cancel anyway, so there is no need to write always. You can write directly 5 into 4 into 3 upon 6 into 5 into 4 to get your answer. Okay, well, this was the best way to get your answer, but there is another way also, that is we are going to pick the ball one by one. So here we know we have to pick 3 red ball. Okay? And we know we have to pick ball without replacement. Okay, so what we are going to do is, first we are going to pick 1 red ball. So 5 upon 6. Okay, now we have picked 1 red ball, so in the box there is 4 red ball now. So the total ball will be 5 and red ball will be 4. So if we pick one more ball from 4 red balls, so we will have 4 upon 5. Hope so you're getting this right. Now we are having a 3 red ball, since 5 is reduced to 4, then reduced to 3. Okay, now we are having 3 red ball, so the total will be 4, right? So 3 upon 4. So you can see this is what you get from this formula also. Okay, so this is the traditional way, but you have to think more in this. but here you can write directly. Okay, so if you solve this, you will get the same answer, that is 1 by 2. This got cancelled, this got cancelled, 3 ones are 3 twos are. Okay, so this is the same answer you can get. Okay, it's better to know both the approach, as this both gives a better clarification. Okay, now let us see this sum. This is of chemical 2017. A box has a 6 red balls and 4 white balls. A ball is picked at random and replaced in the box, after which second ball is picked. The probability of both the ball being red is. So if you see this question clearly, you can see here we have replaced word. Okay, so in first question we were having without replacement, and now we are having replacement sum. Okay, always while solving this ball based sum, you have to tackle the condition first. Okay, so you can see the condition given to us is that the probability of both the ball being red. Okay, so the condition is that both the ball should be red. Okay, so it means first we are picking one red ball, then we are putting back to the bag, and then again we are picking one red ball. Okay, so if we solve it, we will get from 6 ball we are picking one red ball first. So we are picking one ball from 6 red ball upon total ball is 10, right? Now since we have picked one ball and then replace here, it means you are putting a ball back into the bag. Okay, it means the balls in the bag is not going to reduce. Okay, it will remain same, so the total number of ball will be same and number of red balls will be also same. Okay, so you will get 6 here upon 10. Okay, so in both the cases we are going to have 6 by 10 and 6 by 10. Okay, so the answer will be 36 upon 100. Okay, so more specifically 0.36. Okay, more specifically we are finding the probability of red ball and red ball. Okay, so whenever we are going to have a and, we are going to multiply the probability of each red ball. Okay, so here we have the probability of a red ball is 6 by 10. Since the condition is replacement, so the ball will remain same in the back. So for the second red ball also we are going to have 6 by 10 as the probability, and your answer will be 0.36. Okay, using the combination formula also you will get the same thing. Basically first we are picking one ball from 6 red ball. Okay, so 6C1 upon one ball from 10 ball. Okay, so 10C1 into one ball from 6 balls, since the ball in the bag remains same. Okay, so we will have 6C1. basically one ball is picked from 6 red ball upon one ball picked from total number of ball. Okay, so you can see both this formula as well as this tactics give the same answer. Okay, so the answer will be 0.36. Okay, so you can see if you know the best way to solve this type of sum, you can solve this sum very easily in less than 10 seconds. Okay, till now we have seen one sum from without replacement and one sum from replacement. Okay, so from now onwards you can solve all type of sum from with and without replacement sum. Okay, so let's see this sum. Try to do this sum by yourself. This sum is of Me12. A box contains 4 red and 6 black balls. 3 balls are selected at random from the box, one after the another without replacement. Okay, without replacement, note this thing. The probability that the selected set contains 1 red and 2 black balls. Now take 30 seconds and try to do this sum by yourself. Okay, hope so you tried with yourself. Now I am solving this question. Okay, so basically we have to find the probability that the selected set contains 1 red and 2 black balls. Basically we want probability of 1 red ball and 2 black balls. Okay, 2 black balls. So if we try to do this thing by the combination formula, we have to find the probability of red ball first. So for red ball it will be 4C1. Since we are having the operator and here, so we are going to use multiply. Okay, so note one thing, whenever you get and, you are going to multiply. Whenever you got or, you are going to add. Okay, since we are having and condition, so here we are going to use multiply. Okay, then we need to select 2 black balls. Okay, so we will write 6C2, selection of 2 black balls from 6 ball. Okay, upon total C3, so total we have 4 6, so 10C3. Okay, so if you do, you will get 4 into 6 into 5 upon 2 upon 10 into 9 into 8 upon 3 into 2 into 1. Okay, so if you do, you will get 2 ones are 2 twos are 6 5 are 30, 30 to the 60 upon 3 threes are 9, and then 2 ones are 2 fours are, so basically 3 fours are 12, 10s are 120. Okay, so the answer is 1 by 2. This is the answer from the combination approach. Okay, so let's see the basic approach also. For the basic approach, we know we have to find the probability for set contains 1 red ball and 2 black balls. So the combination, it can be red black black, right? or it can be black, red, black, or it can be black, black, red. Okay, so these three are the cases. Okay, basically in this arrangement we can get this set. Okay, so if we solve for this first case, what we will get, probability of red ball, so it will be 4 upon 10. Okay, since we are without replacement, so we will be remaining with 9 total balls, and this red ball will become 3, and we are having 6 black balls, so for a black balls it will be 6 upon 9. And again we are having black balls, 6 from 6 black balls it reduces to 5 black balls, so we are having 5 upon 8, since one ball is also reduced. So we will have 4 ones are 4 twos are 5 ones are 5 twos are 6 3 twos are 3 threes are, and this got cancelled, so we will have 1 by 6. Okay, note this thing, we here we have multiplied because here we are having and. Okay, red and black and black, here also we have black and red and black, black, black and red. Okay, and these are the three cases, so here we will have these cases or these cases, this case or this case. Okay, so for or we are going to add. Okay, so we are going to add the probability of these two cases with this probability. Okay, so for this second case, what we will have, we are picking first black ball, so it will be 6 by 10, then red ball, so 4 by 9, then black ball, so basically 5 by 8. Okay, at the end we are going to have the same answer, 1 by 6, because the multiplication terms are going to be same in the product. Okay, and for the third case we will have the same thing, 6 by 10, then 5 by 9, then for red it will be 4 by 8. Okay, since the terms are same, so we are going to have the same product. Okay, so if we add up, we will get 1 by 6 plus 1 by 6 plus 1 by 6, basically 3 by 6 equals to 1 by 2. So you can see from basic approach as well as from the combination formula approach, you are going to have the same answer. Also in the basic approach, what you can do is you can find the probability of first case and then just multiply with this 3, because we have total 3 cases. Okay, so from this also you are going to have the same answer, 1 by 2. Okay, so these are the various way from which you can get your answer. Okay, now let's see this sum. This is of EC17, a box containing 5 red balls and 5 black balls. In the first draw, one ball is picked at random and discarded without noticing. Now this question is of without noticing its color. Okay, the probability to get a red ball in the second draw is. Okay, so the question is saying a box is having 5 red balls as well as 5 black balls. Okay, in first draw one ball is picked, okay, and discarded without noticing. Basically it is thrown away without noticing its color. Okay, and we have to find the probability to get the red ball in the second row. Okay, so always you have to tackle the condition first. So what we want in the second row we should have a red ball. Okay, in first ball it can be red ball or it can be black ball. Okay, but in the second row we should have a red ball only. So for this we can have two cases, either probability of red ball and then red ball, basically having a red ball in the first draw and then having a red ball in the second draw also, or probability of black ball and red ball. Okay, basically black ball in the first draw, red ball in the second draw. Okay, since we want the probability of red and red, so what we are going to do, so first we are going to pick red ball. Okay, so from 5 red ball we are going to pick one ball, right, upon 10C1. We are going to multiply because we are having and here. Okay, so now we have to pick one more red ball, but since we know in the first draw we have already picked one ball, so now we are having only 9 balls and red balls is 4, so we will have to pick one ball from 4. So we have picked one ball from 4 ball. Okay, upon 9C1, right. You can also directly write it as 5 by 10 multiply by 4 by 9, then we will add it, right, because we have or. Okay, this is basically this thing. Okay, so now we want probability of black and red ball. Okay, so first if we pick black ball, so we will have 5C1 upon 10C1, right, so we will write it as 5 by 10, similar to this. Okay, then we will multiply it because we have and here, then we have to pick red ball. Okay, so for red ball we will have 5 ball only, but the total number of ball will get reduced to 9, right, since we have already drawn one ball. So we will have 5 upon 9. Okay, so now if we simplify it, we will get 5 4s are 20 plus 25 upon 10 9s are 90, right, so we will have 45 by 90. Okay, so the answer will be 1 by 2. This A will be the correct answer. Okay, so you can see, if you know the best way to solve this sum, you can solve this type of sum in just 10 to 20 seconds. Okay, now let us see this sum. This is of IN 2016. A bag contains 5 red ball and 7 green ball. A ball is drawn at random and its color is noted. The ball is placed back into the bag along with another ball of the same color. Okay, the probability of getting a red ball in the next draw is. Okay, so you can see this sum is of with noticing the color. Okay, so the question is saying the ball is picked at random, its color is noted, and then again the ball is placed back into the bag along with another ball of the same color. Okay, so basically, let's say if we picked red ball, we noted the color that this ball is having a red color, then we are placing this red ball again to the bag along with one another red ball. Okay, so in turns we are adding one red ball back to the bag. Okay, let's say we picked a green ball, then we are going to note it color and then we are going to place back into the bag along with one more green color ball. Okay, so now let's solve this question. Always we have to tackle the condition. Okay, so we have to find the probability of getting a red ball in the next draw. So basically at the next draw we want that red ball should be there. Okay, in the first draw it can be red ball or it can be green ball. Okay, so basically there are two cases: probability of first ball being green ball and red ball, second ball should be red. Okay, so that's what I am writing second as red, or probability of red and red. Okay, first ball was also red ball and second ball is also red ball. Okay, so if we solve it, we will get, we want probability of green, so green will be 7c1. From 7 green ball we are picking one ball. Okay, so that's what I am writing, 7c1 upon total number of balls are 12c1. Okay, I can write it as 7 by 12 directly. Okay, multiply because I am having and in the center. Okay, and now since the question is saying the color is noted and the ball is placed back with one another ball, so here you can see since the color was green, so one more green ball is placed back into the bag. Okay, so now we have 8 green ball. Okay, so in total we are having 13 balls, among which 8 are green balls. Okay, but we want red ball. Okay, so the red ball amount is 5 only, so 5 upon 13. Why? Because the total number is increased to 13. Okay, now we have OR, so for OR we are going to have plus. Okay, now the second case is probability of red and red. Okay, so for probability of red, basically 5c1 upon 12c1, so it will be 5 upon 12. We have noted its color and placed one more red ball into the bag, so we will have 6 red ball now, and the total number of ball will be 13. Okay, so it multiply by 6 upon 13. Okay, so if we add up, we will get 7 5 is 35 plus 5 6 is 30, 12 into 13, so basically 156, right? So we will have 65 upon 156. So you can see the answer will be this A. Okay, so what we can conclude is, always we have to use the combination formula. If we have to select 2 balls from 10 balls, then we are going to write 10c2. If we have to select 1 ball from 10 balls, so we are going to write 10c1. Okay, upon total. Basically the probability is favorable upon total. Okay, that's what we are writing here always. Okay, and this basic formula is derived from this combination formula only. Okay, so that's why you will always get the same answer from both the approaches. Okay, so that's it for today. Thank you guys.